Determine the internal normal force, shear force, and the bending moment acting at point C in the beam. To solve this problem, first of all, we need to find our external reaction forces at A and B. So at A, we can have both horizontal and vertical reaction forces because it's pin connected. And at B, it's just a roller or ball joint. And here we only can have a vertical reaction force. Now we can find our first external reaction force by taking moment either at A or B. I'm going to take moment above the point A, where we have counterclockwise 20 kilonewton per moment on the left hand side of this beam. Then we have our counterclockwise action By, and it's 2 meters away. And then we have our clockwise 10 kilonewton, and it's 4 meters away from our point A. Solving for By, we get our solution for By as positive 10 kilonewton. Now we can sum the forces in y direction in order to find our solution for Ay. So we're going to have positive Ay, negative positive By, which is 10 kilonewton we've just found, and then negative 10 kilonewton external reaction force because it's going downward, all equals to 0. Solving for Ay, we get our solution as 0 kilonewton. And for horizontal reaction force at A, we don't really have to do anything because we can see that by inspection that there isn't any other horizontal reaction force acting on this beam. Therefore, it's going to be 0 kilonewton. Now that we have all the external reaction forces, we can cut our beam at C to find our required solutions for this problem. So now we can either cut this beam and take just the left part of this beam or the right hand side. I'm going to be taking the left hand side, and we solve it by drawing its free body diagram. So the free body diagram is going to look something like this, where we have our clockwise 20 kilonewton per meter, counterclockwise 20 kilonewton per meter moment on the leftmost part of this beam. And then at point E, there isn't anything because we just found that everything is 0 kilonewton. And then at C, we're going to have our shear vector, our normal force vector, and our moment at C. To begin solving for this beam, we simply need to sum the forces, or we can start by taking the moment above the point C and assuming counterclockwise is positive. So we can have our moment MC, and then which is counterclockwise, therefore positive, and then we have counterclockwise 20 kilonewton per meter, all equals to 0. Solving for MC, we get a solution as negative 20 kilonewton per meter. Now we can either keep it like this or we could switch signs and have this solution as positive, but that's not a concern for this problem, and we can keep it as it is. And then finally, we just have to sum the moment forces in y and x direction. And by just the visual inspection, we know that we don't have any horizontal or vertical reactions forces acting on this part of the beam. Therefore, we know our shear is going to be 0 kilonewton, and our normal force at C is all. Determine the internal force, shear force, and bending moment acting at point C in the beam. Just like the first problem, we have to first of all find our external reaction forces. We know Ax is going to be 0 because there isn't any other external horizontal force acting on this beam. And then we just need to find our Ay external reaction because we're going to use left hand side of this beam to find our internal forces. Okay, so to solve, first of all, let's convert our uniform distributed load into point loads. So our first load, which is 4 kilonewton, and that's along 1.5 meters, it's going to be 6 kilonewton. And similarly, the other one is going to be 12 kilonewton. Now that we have our pointer loads, we can find our vertical external reaction at A by taking moment about the point C, pardon me, B. So we can have at B we can have counterclockwise 12 kilonewton, and it's 0.75 meters away from B. Then we have counterclockwise 6 kilonewton, and it is 2.25 meters away. Then clockwise AY, and it's 3 meters away, all equals to 0. So for AY we get a solution as positive 7.5 kilonewton. Now that we have our required external reaction forces, we can draw the free body diagram of the left hand side from point C. So we have our AY to 7.5 kilonewton. And then we have 6 kilonewton halfway through and 0.75 meters away from each side. And then at C we have our shear force. Our normal force is going to be 0 because we know that there isn't any horizontal reaction force on it. And now to find our moment at point C, all we have to do is take a moment about the point C, and assuming counterclockwise is positive, so we're going to have positive moment at C. Then we have counterclockwise 6 kilonewton, and it's 0.575 meters away. Then we have our clockwise AY, and it is 1.5 meters away, all equals to 0. Solving for MC, we get a solution as positive 6.75 kilonewtons times meter. And then finally, we just have to find our shear, which is simply going to be sum of forces in y direction. So we have positive 6 kilonewton, negative 7.5 kilonewton, and then we have negative shear force, all equal to 0. Solving for shear force, we get our solution as 1.5 kilonewtons positive.